In November 2025, deep space instruments monitoring the Sun detected a faint, steady magnetic pulse rising out of the chaotic solar wind. ESA's Solar Orbiter and NASA's Parker Solar Probe both recorded the same repeating waveform. Triangulated data traced the source to the path of 3I Atlas, an interstellar comet plunging through the inner solar system. Comets are typically inert, loose collections of frozen rock, dust, and ice that lack metallic cores or internal magnetic fields. A coherent magnetic signature on an interstellar comet is a physical paradox, forcing a reassessment of the composition of objects arriving from the galactic disk. The magnetic field fluctuates exactly 16.16 hours, aligning with the mechanical rotation of the comet's nucleus. This magnetic rhythm is linked to a physical force known as the A3 term, which is pushing the comet perpendicular to its expected orbital plane. As the comet approached Jupiter's orbit, this sideways push increased by nearly 15% in 24 days. This growth suggests 3I Atlas carries a structural complexity that standard orbital models cannot accommodate. Researchers analyzed whether this movement resulted from standard cometary outgassing, the rocket effect created by sublimating ice. The force is far too strong to be explained by venting gas, and the vector is pointing in the wrong direction. Another hypothesis suggested that solar winds were inducing a temporary magnetic field in the comet's dusty coma. Solar induction at this distance would be chaotic and collapse within minutes as plasma density fluctuates. The 3I Atlas signal remains stable and coherent across multiple rotations. Since external solar forces and surface venting are insufficient, the source of this magnetic engine must be located deep within the comet. This has led researchers to investigate a process called inductive self-amplification. This mechanism requires 3I Atlas to harbor a massive, nickel-rich core forged outside our solar system. As this metallic core spins through the Sun's background magnetic field, it acts as a dynamo, generating internal electric currents. These trap passing solar plasma, creating a feedback loop that boosts overall magnetic strength. This helical traversal allows the comet to grip the magnetic fieldscape and spiral forward. 3I Atlas is actively navigating the solar system's electromagnetic grid. These unique dynamics have led to a new classification for interstellar objects, torque-entrained interstellar objects, or TIOs. Chemical isotope data suggests 3I Atlas originated in the galaxy's thick disk during cosmic noon, roughly 9 to 13 billion years ago. While our solar system formed in a quiet environment, 3I Atlas was born in a high-shear, metal-rich region and exposed to galactic cosmic rays for billions of years. These ancient building blocks are more chemically diverse and dynamically capable than the material in our local neighborhood. Researchers are currently debating the origin of the comet's orbit, with some analyzing the specific energy requirements of its path. This contour plot shows that 3I/Atlas is on a trajectory that requires an unusually low delta-V to intercept and rendezvous with Jupiter. The JUICE and Europa Clipper missions are preparing for deep space intercepts to capture the first in-situ data of the comet's magnetic anomaly. Regardless of its origin, 3I/Atlas reveals that the physical rules governing our local planets are only one part of a much larger, more diverse cosmic story. The upcoming telemetry from these spacecraft intercepts will finally identify the mechanism behind that magnetic heartbeat. Subscribe and follow the channel to see the results of those data dumps as they arrive.